Hello everyone. In this video I am going to discuss Thevenin's theorem problem number 2, and the problem: determine current in 20 ohm resistor using Thevenin's theorem. And this is the circuit: 3 resistors and 2 voltage sources, 40 ohm, 20 ohm, 60 ohm, and they are asking to find the current flowing through this 20 ohm resistor. And according to the procedure, we are finding current in this 20 ohm resistor. Then procedure, first step, already we are discussing Thevenin's theorem introduction and procedure in previous lecture. Please go through that video if you have any doubts. Step 1, please identify the value of load resistor. Remember, the load resistor value is nothing but in which resistor we are finding the response. That resistance is called as load resistance. Generally, that resistance we are considering as a load resistance. Remember, this is very important. In some of the problems, already in the problem they are mentioning RL is equal to something value, and in that case we no need to identify the value of load resistance, directly are giving. But in this problem, just simple resistors are given and they are asking to find the response in 20 ohm resistor. Means this 20 ohm resistor is called as load resistor. Okay, step 1. And step 2, calculation of Thevenin's voltage. And for that, we need to remove load resistance from the circuit. And find voltage across this open circuited terminals. Remember, and draw the circuit. And after removing load resistance and find voltage across the open circuited terminals, for that we need to draw the circuit, modified circuit. This is 40 ohm, 60 ohm and 65 volts and 120 volts, and these are the 2 points in between we are finding Thevenin's voltage. First, find total current in this network. Simple, by applying simple, this is a simple circuit. Okay, now find current, total current I. Okay, by applying KVL, okay, we are starting from 40 ohm resistor. It is minus 40I and minus 60I. In 65 volt source, current is flowing from positive to negative. This is we are considering as a voltage drop. That's why it is minus 65. And in 120 volts, current is flowing from negative to positive, and lower potential to higher potential. Voltage is rising, and then we are considering plus 120 volts is equal to 0. And I think everyone knows the statement of KVL: in any closed path, the algebraic sum of all voltages, means voltage drops and voltage rise, is equal to 0. And remember, when you are writing KVL equation, no need to write units of the resistance voltage. Just write KVL voltage R into I, and this is direct voltage. Write 65 only. Don't write 65 volts again. Is it clear? Remember. And then total current, find minus 100 I and 120 minus 65, and it is plus 55 is equal to 0. From this, I is equal to 55 by 100. That is equal to 0.55 amperes. 0.55 amperes. And this is the current. This is the current flowing through this circuit. Yeah. And what is our aim? Our aim is to calculate Thevenin's voltage. Where we are calculating Thevenin's voltage? In between open circuited terminals, in between load terminal. This is the points. Okay. For that, draw this circuit again to calculate VTH. From this, after finding total current, this is 65 volts, 60 ohms, 40 ohms, and 120 volts. Okay, in between these 2 points A and B, in between A and B, we are finding voltage. For that, draw the one voltmeter, voltage source. Draw one voltage source. It is VTH. Yeah, and to find VTH, consider this closed path or this closed path, your wish. And in any closed path, we are getting same value. Suppose I am considering first one. Okay. Yeah, and by applying KVL, by applying KVL, write KVL equation. 40, this is resistance, it is minus 40I, and this, from this VTH, current is flowing from positive to negative, it is drop, minus VTH and plus 120 equal to 0, and here the current is flowing from negative to positive, that's why I am taking plus 120. And then we are finding current. Okay, minus 40 into 0.55 minus VTH plus 120 equal to 0, and from this VTH is equal to 120 minus 40 into 0.55, 22, 120 minus 22, it is 98 volts. VTH is equal to 98 volts. Don't forget to write units. This is very, very important. VTH is equal to 98 volts. This is step 2. Step 2, we are calculating VTH. First, we are removing load resistance and then find total current in the network. By applying simple KVL. After finding current, we are finding voltage in between A and B terminals. We need to find voltage in between A and B terminals. And suppose if you are considering this loop, and then also we are getting same response. Just verifying. The current is flowing like this. Okay. Yeah, same. By applying KVL. Yeah, this is 60 means voltage drop, obviously. It is minus 60I, and the current is flowing from positive to negative. It is minus 65, and VTH negative to positive, it is plus VTH equal to 0. Then VTH is equal to 65 plus 60 into I, and 65 plus 60 into I value 0.55. 65 plus 60 into 0.55. It is 98 volts. We are getting same answer. Yes. In the exam, you need to consider any one closed path. Any one closed path to find VTH. Okay. Okay. This is second step. And in third step, we are going to calculate RTH value. We are going to calculate RTH value. Step 3. Calculate RTH means Thevenin's resistance. To calculate RTH, there is a procedure. In a given circuit, there are two voltage sources. The two voltage sources can be replaced by short circuit. Replace 120 volts and 65 volts by short circuit. And replace RL by open circuit. Replace RL by an open circuit. And remember one thing, when you are calculating RTH, the circuit consists of only resistors. Yeah, draw the circuit. Two voltage sources can be replaced by short circuit and replace RL by open circuit. And in between open circuited terminals, we are finding RTH. Remember, this is short circuit and this one is also short circuit. Two voltage sources. This is point A and this B. In between these 2 points, we are finding RTH. In between these 2 points, we are finding RTH. Remember, this is very, very important to draw the circuit, modified circuit exactly. Okay, and this value is 40 ohms and this is 60 ohm resistor. 40 ohms and 60 ohm resistor. And to calculate resistor and redraw the circuit again, then it is easy to understand. First, I am taking this A. For A, 2 resistors are connected in parallel. Okay, point A it is 2 resistors are connected in parallel, 40 ohms and 60 ohms. Okay, and from A to this 40 ohm is connected to point B, and from A to this 60 ohm is connected to point B. Means in between 2 points, 2 resistors are connected in parallel. This is the redraw circuit, modified circuit. Then it is easy to calculate RTH. Now these two are connected in parallel. Then RTH is equal to 40 into 60 by 40 plus 60 plus 40. That is equal to 24 ohms. RTH is equal to 24 ohms. Okay. Yeah. Everyone is confused to draw this circuit. 40 and 60 are connected in parallel. All are assuming these two are connected in series. And if you are drawing exactly what you are writing here, 120 short, 65 short, and RL replace. In between open circuited terminals only we are finding RTH. Remember, in between open circuited terminals only we are finding RTH. This is the path. 2 points. In between 2 points, one resistor is connected like this and another resistor is connected like this. And this is the modified circuit. Yeah. Next, step 4. Finally, we are calculating load current. Step 4. Calculate load current IL. Okay, now how to calculate load current IL? For that we need to draw the Thevenin's equivalent circuit. Draw the Thevenin's equivalent circuit and connect load resistor RL across it. In second step we are removing RL, then finally again we are connecting load resistance across it. Yeah. First draw the Thevenin's equivalent circuit. Resistance, voltage are in series. Resistance, voltage are in series. This is RTH plus minus, this is VTH, A and B terminals. And for this equivalent circuit we need to connect load resistance. This is R, and here we are finding current IL. Okay, IL. Okay, write the value of VTH, RTH. VTH 98 volts and RTH 24 ohms and RL 20 ohms. Okay, then load current. Therefore, current flowing through the load IL is equal to VTH by RTH plus RL. That is equal to VTH 98 volts and RTH 24, RL 20. 98 by 24 plus 20. It is 2.2272 amperes. Therefore, IL is equal to 2.227 amperes. This is the way we are calculating the response by using Thevenin's theorem. Simple. You need to follow the procedure step by step. Definitely you will get a good marks and correct answer. Okay. Follow the procedure. As per procedure, we are modify the circuit and we are finding the respective quantities VTH, RTH and IL by following the procedure. For that, you need to prepare the procedure first. Okay, now don't by heart the problems. Okay, you need to prepare procedure. For that procedure only we are solving the problem step by step. Okay, thank you.